Can everybody hear me? Good. Look, if I haven't already introduced myself, my name is Stuart Rothwell, and I'm here representing the Australia section of the American Society of Civil Engineers, and I apologise for not having an American accent. Our co-sponsor for the event is the Council for Tall Buildings and Urban Habitat, and Craig Gibbons is their chief representative here, and he'll be speaking later on today, and there are a number of people here who would be associated with that organisation. So welcome and thank you for coming. One of my mild passions, and my wife thinks this is a bit tragic, is collecting postcards of tall buildings in the United States. And these are some from the collection, and the interesting thing about these buildings is at some stage they've all been the tallest building in the world. The top left-hand corner is the Singer Building, and I think my notes tell me the Singer Building's from 1908, and at the time it was 187 metres. Well, it's never been 187 metres, but I've converted that from the feet that it would have been. It was 187 metres and had 47 floors. And it was soon after surpassed by the Metropolitan Light Building, which is the bottom right-hand corner there. That was in 1909. It was 50 floors and it was 213 metres high. And then the Woolworth Building, which was built in 1913, top right-hand corner, it was 58 floors and it was 241 metres high. And then, of course, the Empire State, which is the left-hand corner, which is really the still the hallmark, I guess, in tall buildings, even though it's no longer even close to being the tallest. It was 102 floors and 381 metres tall. Now, to put that in a bit of perspective, the Burj Khalifa, which now holds the record as the tallest building, constructed around 2004, is 163 floors and 830 metres tall. And you might think, well, we must be a lot smarter now, or we must be more industrious or more enterprising, but at the time they were really the ultimate in engineering. The engineers then were no less smart than we are, and the people who built them were no less industrious. But what has changed, I think, in the last 100 years is that we've kept on learning and growing as a profession so that we can actually now do the sorts of things that they probably only dreamed of in those days. So I'm just going to quickly go through what we've got for you today. Craig Gibbons is going to give an overview of tall buildings as they stand at present. Richard Cass from Bonacci, and Craig's from Arup, by the way. Richard Cass from Bonacci is going to, I probably haven't said that right, have I? Bonacci. He's going to give us a bit of an overview of what developments, what current developments are happening so that we can design our buildings better. Andrew Gentner is going to do the sustainability section. Then Leighton Cochrane, who's only recently returned, when I say recent, the last 2 or 3 years, returned from the US, where he had a lot to do with development of wind engineering in the US, and continues that in Australia today. He'll do a section on wind. Jose Torero is coming to do facades, we hope. And then, lastly but not by any means least, Harry Poulos. I mean, anyone who's driven a pile or bought an in situ pier in this country must at some stage have said to themselves, what would Harry do? So I'm really looking forward to that. But without further ado, I'd like to pass it over to Craig Gibbons. Thanks, Craig.
Thanks, Stuart. Right. I've been designated IT person for the day. I know that the people here from Arup can't believe that, but yes, it's true. Here we go. Looks about right. Thank you. Yeah, on behalf of the CTBUH, I'd just like to say thanks, Stuart. You put a lot of effort into organising this, and it's great to collaborate with ASC and getting a bunch of tall building enthusiasts in the room and to just talk about some of the issues that we face. So we're in for an exciting afternoon. I thought I'd give a little bit of a short piece, just focusing on some tall building trends that I'm sure will influence our thinking. It's predicted that in 2050 there will be 9 billion people on the planet, and incredibly it's predicted that 75% of those people will live in cities. It's an incredible number, but clearly is putting a lot of pressure on urbanisation, a lot of pressure on our cities, and we, as people involved in the design of cities and the buildings within them, need to take these challenges into account. They need to inform our thinking because urbanisation, mass urbanisation is happening. And just in support of the pundits, here's a graph. Hopefully you can see that from the back, but it shows the rise of the high-rise. Recently, the number of buildings in the world which were over 200 metres reached the 1,000 mark, and you can see there that it's a staggering rate of progression, 400% more than there were in the year 2000. The demand to live in cities is fueling this, and as you can see, I like graphs. But this is a little bit of a plug for the CTBUH Skyscraper Center. I suggest if you're into graphs and data and statistics, go and have a look at it online. It's an interactive database where you can pull out all sorts of statistics about buildings anywhere in the world. And this is a distillation of that, just showing the built and proposed buildings above 200 metres here in good old Australia. 2000 on the left-hand side up to about 2020. So you can see the cluster of activity on the right-hand side, which we're all pretty familiar with, together with the blobs showing the location. There are in fact two blobs there for those at the back, two blobs for Queensland, one in Brisbane, one in the Gold Coast. But a lot of frantic activity. And, allied to that, this is a slide I pinched from the Urban Task Force in Sydney, where they presented 3 visions for what Sydney might look like in 2050, mindful of this mass urbanisation and densification. Clearly, the need is to go taller. We at Arup have been having a number of conversations with the City of Sydney, looking at the implications of buildings exceeding the rather prehistoric height limit, and I think we can say that in the not too distant future you will see that limit raised, a bit like it has done in Melbourne recently. So I just want to get across a few trends. This is much a personal view, but some things that are definitely happening and things that we need to be mindful of is that there are many more slender buildings around. Well, buildings are becoming more slender. Smaller CBD sites, wanting to go tall, the buildings get more slender. New timber, it's all the rave at the moment. How tall can we go with timber? And also a little bit about the greening of buildings. I say why, and well, I think why not? Makes for a better looking skyline, that's for sure. I love this photo. This is New York, good old Central Park over there in the distance. Those buildings that look like they've been photoshopped in are indeed photoshopped in, and those are proposed towers in New York. Skinny towers, pencil towers as they're sometimes called. They are very, very slender, and they're meeting the demand for increased population within New York, going taller and more slender. And there's 2 that are really worth talking about briefly, and that's 432 Park. Slenderness is basically the height of the building divided by the minimum width. Now, back 15 years ago, when I was doing a lot of buildings in Asia, anything above 8.5 was seen as pretty slender. As you can see, this one here is an aspect ratio of 15, and incredibly, this is the proposed sale, 111 West 57th, where it's got an aspect ratio of 23. Very, very slender indeed. And clearly that introduces all sorts of challenges in terms of their design. We'll hear from Leighton later on, well, specifically on 432. He's got some interesting videos of what it means as we design more slender buildings. And look at that. Wow. Isn't it fantastic? The apartments at the top, the sale price is of the order of about 100,000 US per square metre. But what a lovely view. I was actually talking to an engineer from in New York recently, and they were working on a skinny tower. And I was amazed, but he said this is one of the trends whereby rather than, because there's no height limit in New York, there is a restriction on GFA. What they're doing is taking the big chunk of GFA, maybe 50, 60 stories, and just hoiking them up into the air. So the bottom of some of these skinny towers is in fact hollow, no floors. And it's all to get that view of Central Park and, you know, megabucks per metre squared. So a little bit insane, but that's certainly, you know, the way it's going over there. And that theme is continuing around the world. I've shown here one or two familiar examples of slender towers. Phoenix Apartments, we were talking about that before, Leighton. Meriton, just around the corner, slenderness of about 12. And there are a whole bunch of buildings that are going on in Brisbane of the range of 10 to 14. In fact, I was talking just before with some of the speakers and understand there's one of an aspect ratio of 15 and one in Melbourne, Leighton, which is 25. Well skinny. So, you know, this is a trend. And we've got to meet the challenges of how we design these buildings. Actually, one of the biggest challenges tends to be doing the basements for these things. You know, where you've got a small site needing to get a car park provision in, that is actually proving quite a challenge and giving rise to all sorts of stacker systems to help with the challenges of parking cars. Timber. As I say, timber is very much in vogue at the moment, thanks to new engineered products. I think front of the pack is this, cross-laminated timber, the ability to make mass timber sections in a way which has particular structural advantages. It's quite light material, quarter of the weight of reinforced concrete. But I think the big advantage with it, and this is where I do see it becoming more and more the mainstream, is that it's dimensionally stable. In other words, you can make it somewhere, take it to site, and there's a good chance it's going to be the same dimensions. And it's very readily built for design for manufacture. It can be milled, shaped, etc. By computer-controlled machines, and you know, is very, very good at basically removing work from site and putting it into prefabrication facilities. And of course, it's got some incredible sustainability benefits as well. This is the Forte Hotel in Melbourne. It was the world's tallest timber building, 32 metres tall, 10 stories. Lend-Lease refined the art of doing timber buildings on the back of this. Key things were, though, that it is very straightforward to erect, very quick. And you can see from the statistics there just how easy that was. Timber's getting higher. This, I think, is the latest tallest building in timber. It's the Tree Apartments in Norway, 14 floors, 62 apartments, 49 metres tall. A different way of approaching the problem. Basically, it's a diagrid on the mega frame on the outside in glulam, and the apartments inside are 4-storey pods of timber, which are retro-installed. And whilst there's a number of pure timber buildings that are vying for the tallest, this is one of them. the Forte apartment buildings in the Netherlands, 73 metres. And some pretty interesting looking cantilever balconies, which should be interesting in timber. But this is very much a trend. People ask me, how tall can we go in pure timber buildings? And I think I'm mindful of one that might be 84 metres in Austria. But it's I think this is about the limit. You go beyond this and you're having to vertically pre-stress elements because of strength and stiffness issues. So I think the prospect of going taller means that we need to think a little bit more differently. And I'm a big fan of what I call the happy hybrid. It's a mixture of timber and conventional construction. And this is a good example of it. This is something we did with Korean Romberg and the Austrian government. The challenge was to make a 40-storey tower using predominantly timber. And the way to do that is to use a conventional reinforced concrete core, glue-lam timber floor panels, which in this case are composite with a sort of preset concrete slab, and a perimeter timber frame. It was a pretty effective approach, pretty quick to construct, and lent itself to office usage. You can see, we're getting about a 9.6 metre span with an overall structural depth of about 360 mil, which ain't bad. And we were fortunate enough to be able to do a demonstrator project, a prototype of the design. And this is it. It's only an 8-storey building, but it illustrates the principle and develops the construction methodology and the design approach. So you can see it's got a conventional reinforced concrete core, slip-formed, and then the floors follow on behind it. Interestingly, the floor cycle time was 1 day per floor. Very quick, very easy. And here you can see one of the glue-lam and concrete slab panels, prefabricated, installed. The slab, if you've got really good eyesight, you can see 2 holes in the slab panel. That goes onto those dowels that are poking up out of the columns. Very, very quick and effective. And when you've put in the last panel, that's what it looks like. It's essentially complete, no wet construction involved, very, very efficient and effective. And that's what the building looked like on completion. I think, it needs a little bit of architecture thrown at it, but, as a prototype, I think it's pretty good. Demonstrates the principle. And we're now doing some research with CTBUH to actually take this to the next level, bring it on more mainstream. But I do think that, buildings that have taller buildings, taller than the 20 or so stories I mentioned before, will need this, as I say, a happy hybrid, a combination of materials in order to be really and truly effective. And I think you're also going to see a lot more of this. Steel and timber. Timber is pretty difficult to keep, well, not difficult, but it's quite expensive to connect together. So the logic is you make the connections of the timber bits as simple as possible, i.e. CLT slab panels as the floors, and do all the tricky stuff using conventional technology, i.e. steelwork. So this is being used in a number of locations. With the advent of CLT production here in Australia, I think this is probably something that we're going to see much more of. And just a couple more slides. Again, another little bit of a plug for CTBUH stuff. Yeah, green buildings. And I mean green in the sense of visibly green. This is all these are downloadable documents from the CTBUH website. Look out for tall buildings in numbers. There's great stuff on all facets of different aspects of design. This one is green walls in high-rise buildings, and you can see from that map it's pretty extensive in terms of the push and initiatives that are being undertaken globally. A lot of activity. One area to mention here, of course, is Singapore. Singapore has very strict rules now about the amount of green, visible green, that appears on a building moving forward. And I think that's a great thing. It really has the potential to redefine the skyline. And just one or two examples. This, again, is an absolutely fantastic building, One Central Park, Sydney. It won the Best Building Award, CTBUH Best Building Award back in 2014. It looks impressive there in the photos. It looks mightily impressive if you drive past it. It just stands out and looks interesting. And looks a damn sight better than many buildings I've seen. And in the same vein, this is the Bosco Verticale, which means vertical forest, in Milan, Italy. And this one won the CTBUH World's Best Building in 2015. So there's a little bit of a trend there, as you can see. You know, if you want to win the world's best building, you know, be good if it's a little bit of green on it. But this is a fantastic project. Milan is very seismic. And again, it's a little bit of a plug for some publications which are dedicated to promoting greenery on buildings. This is a research document. It's one that Arup sponsored. And it goes into all aspects of the design of the landscaping on this building. It's a rip-roaring read. And certainly, you know, for the engineers out there wanting to have discussions with architects about the potential to green buildings, that's a good guide to buy them for Christmas. So, final slide. It's a repeat of my first slide, really. If we don't really be very conscious about things, the way we plan cities, then there's a good chance there'll be many cities in 2050 that could look like that. That's what we want to avoid. You know, we want to think about the shape and form of our buildings, how they free up the groundscape. And we want to think about the materials that we use, timber. And we want to think about greening buildings, just to make, well, the city look a damn sight better than this one. Let me leave those thoughts with you. Thank you very much.